So we are going to be on page 6 of your reference table. So it's the same page we've been working on the past few days. We've worked on the top, the rock cycle, which remember the rock cycle is best used for figuring out what happened to a rock, so how it formed, by reading this reference table backwards. So we're going to look at igneous rocks. And you're going to see, I can ask you, how do igneous rocks form? Again, you read it backwards. It's from the melting and solidification of magma, they turn into igneous rocks. Now, yesterday, no, actually it turned out to be Monday and Friday, we went into a little bit more detail about igneous rocks. We did the extrusive and intrusive igneous rocks. So hopefully you remember that intrusive form inside Earth's surface, which because they're inside, the layers of the Earth act like a blanket and they cool slowly. And then again, because they cool slowly, they have large crystals. Now, I did say these are the only notes we're ever going to do on intrusive and extrusive, and that's because you really don't have to memorize too much about this, because we're now going to look at the igneous rock chart, which is right below where we've been working on page 6. So I know you really can't see mine up on the board, so I'm going to need you guys to look on your own if you can't read mine. So there's a couple things going on here. So first of all, if we just look at the whole igneous rock chart, it's the whole bottom half of the page. But then when you get there, it's almost like there's 3 sections to this reference table. We're going to break it apart bit by bit. There's so much going on this reference table that I wish we could just take notes on the reference table. Now, because there's no room to do that, you'll see on page 15, that's basically what I made. I plopped the reference table into your notes, and then I put little boxes around the reference table for us to take notes right basically on the reference table. The igneous rock chart, so this rock chart that's on page 6 is still just another dichotomous key. It probably looks nothing like the ones you've used before, but it will work the same way, and I'm going to show you how we're going to go through that. So basically what we're going to do is we're going to put notes in each bubble. I'll discuss it as we go along, and you'll see how it works. So again, we're on page 15 in your packet, and you'll see that each bubble points to a certain spot on that reference table. So we're going to start with, actually, before we even do that, we did the dichotomous key for minerals. What did we look for with minerals first? What was the first thing we did to eliminate? Yep, just we looked at their luster to see if they were metallic or non-metallic. There is a first thing we're going to look at here on the igneous rocks. Can you guys take a look and see what that might be? How it's formed, or where it's formed, in fact. Whether it's, so it's the environment of formation. So you'll notice there's 2 choices again, intrusive and extrusive. So what we're going to do is just remind you we're going to start here with this bubble right here. What does extrusive mean? And how does it cool? Yep, cools quickly. Can you read this? Is it too blurry? Cools quickly on Earth's surface. And then the bubble below that is pointing to intrusive. And what do you remember about intrusive? Yep, how does it cool? Cools slowly, deep inside Earth. So the key there is the inside. Now you may notice that there's some words underneath the word intrusive and extrusive. So right here underneath the word extrusive, I know you can't read mine, but can you read your own? What does that say? Okay, so the extrusive says volcanic. The intrusive says plutonic. Now I know plutonic probably means nothing to you, but when you hear the word volcanic, what do you start to think about? A volcano. And what do you picture in your head? Yep. So my guess is for volcanic, you're actually picturing some sort of volcano with lava shooting out of it, right? Where does that lava shoot out onto? The ground, on Earth's surface. So in case you forgot, what does extrusive mean? It has the word volcanic there to help you remember. So hopefully you picture a volcano with the lava erupting on the Earth's surface. Again, intrusive says plutonic. I don't think that helps you at all. Just know that that word is there. So if the region says plutonic igneous rocks, all they're saying is intrusive igneous rocks. So not rocket science there. Now on Monday, I then implied you needed to know that intrusive igneous rocks always have large crystals. Extrusive either have small or no, which is true, but you really don't even need to memorize this because the reference table shows you. So you may still have your Post-it notes left over from the other day. If you do have them, that might come in handy. But if you notice, so these, I guess I failed to mention, these are the rocks. These are the igneous rock names here. You're welcome to write that there if you didn't realize. So rock names. But what you'll see here is the intrusive. If you take this box for, I'm sorry, extrusive. So this box right here, if you follow that line over, it'll actually show you in the next column right here, the crystal size, and it actually gives you a measurement. So there's two types of crystal sizes for the extrusive. Non-crystalline, what does that mean? Non-crystalline, no crystals. And then it says less than 1 millimeter. So you don't even need to memorize that they make no or little crystals. For that box there, for the crystal size, the only thing I do want you to remember is the longer the time of cooling, the larger the crystals. And again, you don't even have to memorize it because it is right there. So it says the longer the cooling time, the larger the crystals. And it tells you again, right there, non-crystalline, less than 1 millimeter. Do you guys know how big a millimeter is? Really small. It's so small. Does actually anybody see my ruler? I know I had one here. Maybe I put it away. A millimeter are these little lines over here. That from my fingertip to the top of the pencil or top of the ruler is 1 millimeter. You should see that a millimeter is about how fat the tip of your pencil is. So it's not really big. So your tip of your pen is about a millimeter, give or take a little bit. So if that's a millimeter, that's a tiny, if it's less than that, it's a tiny crystal. Are you guys familiar with glitter? If you could get one individual piece of glitter out, can you picture doing that?
No.
It'd be really small, but it'd be about a millimeter. That's how one little piece of glitter is a little bit less than a millimeter. So we're talking small. Yeah. I have no idea. But anyway, that's what the extrusive ones are. If we then look at the intrusive, again, following that box over, the intrusive are 1 to 10 millimeters or larger than 10. So if that's 10 millimeters, are 10 of those, it's a centimeter. And I like to estimate that at about how fat your pinky is. So a millimeter is about the tip of your pen. 10 of them is about the tip of your pinky, how wide it is. So those are ones you could see, bigger than a piece of glitter. The next column over is texture. You might look at those names and think, what would you think glassy means? Looks like glass. It doesn't. It's actually describing a texture. And it even tells you flat out what the word glassy means right here. Glassy means non-crystalline. So yes, this one is glassy. It looks like glass. That's helpful. But this one is also glassy. Now, does that look like glass to you? It does not. So what does it mean again to be glassy? No crystals. And that's what we're going to list right here. So in the texture box, we're going to just list the 4 choices. So glassy, fine, coarse, and very coarse. And then just list what they mean. And again, do you have to memorize this? You don't, because it's right there. Glassy is non-crystalline, so no crystals. Fine is less than 1 millimeter. Coarse is 1 to 10 millimeters. And very coarse is 10 millimeters. 10 millimeters or larger. So I'm just going to do 10 millimeters plus. Again, you don't have to memorize any of this. It's just right there on the reference table. You just need to remember to look. Again, so glassy does not mean looks like glass. Same with the word coarse. It has nothing to do with like touching it and it feeling coarse or rough. It has to do solely with the size of the crystals. We looked at granite before. This is granite. Each one of these chunks are crystals. And as you can see, they're all still smaller than my pinky, but bigger than the tip of my pen. So this is going to be a coarse rock. Texture is continued here in this column. And the only thing that's listed there is the word vesicular. See if from the reference table you can figure out what the word vesicular means. Gas pockets. It says right there. Vesicular, and then in parentheses, gas pockets. It's when there's holes in the rocks. I said air pockets, but gas pockets work too. What this means is they cooled so quickly that air got trapped. Cooled so fast that air was trapped inside. And these are the rocks that have holes in them. You can see this one. Those are all holes. Very low density and full of holes. And the last couple of boxes here all have to do with this middle section of the reference table. Super easy. Color, density, and composition. For color, all it means is if you're to the right on this side of the word color, you have a darker color. If you're on the left, you have a light color. If you're in the middle, they can't really decide, are you light or dark? So they kind of just ignore it. Same with density. This side higher, left side lower. And then composition gets a little weird, but if you're on the right, you're what's called mafic, which just means, and it says it in parentheses at the bottom, so you don't even have to memorize it. Mafic just means rich in Fe and Mg, so iron and magnesium. And then on this side, felsic, rich in silicon and aluminum. So again, just a lot of that. So this bottom half is super easy. All we're going to say is what happens on each side. So color, right equals dark, left equals light. Density, right equals mafic, left equals oh, not mafic, right? Sorry, I got ahead of myself. Right equals high density. Left equals low density. And then composition. Again, right equals mafic. And all mafic means is rich in Fe and Mg. Left equals felsic, which just means rich in Al and Si. And the very last box is the minerals present. Which just means what minerals are in each rock. And that's the bottom half right here. So as you can see, these names right here are all minerals that we did on the back of the reference table. These are the minerals that are in each rock. So as you can see, each rock, like the word granite right here, has its own box. If you look underneath that box and any of these symbols show up, those are the minerals that are in that rock. So if we got polka dots, then we got potassium, feldspar. These polka dots, we have quartz. So again, the minerals listed below the rock. The minerals listed below that rock are the make up that rock. So anything listed below it are the rocks that are found inside that rock. That is all the information that's on that reference table. And I am going to have you guys do questions 1 through 12 for homework. That's on page 17, I should say. So I will also mention that not all my classes had the same homework today. I will post on Teams what each class had. And that's just because if you guys didn't know, I was absent this morning and different classes took different amounts of time for the quiz. In the end, I promise everybody will be doing the same pages for homework. Period 3 did them during class this morning and for homework tonight. Period 5, 6 didn't get homework tonight yet, but they'll get double the homework tomorrow. And you guys are just getting one of the 2 pages. Keep in mind, everybody will do the same homework. Just know what you have to do. Don't ask somebody else because they might have had different homework.